Mangoes did not become global by accident. They did not conquer supermarket shelves because people suddenly became romantic about tropical flavors. They became global because agriculture learned how to scale biology with the precision of industry. Today, mangoes are no longer seasonal luxuries tied to geography. They are engineered products, optimized, forecasted, transported, processed, reformatted, repackaged, and redistributed with mathematical predictability. What once depended on climate luck now depends on logistics. Before a single fruit reaches a conveyor belt or a juice bottle, the system begins with land that has already been redesigned for efficiency. Modern mango farms are not chaotic forests. They are geometric systems. Tree spacing is calculated to the centimeter. Soil chemistry is corrected through laboratory analysis. Irrigation is automated through sensors buried underground. Wind patterns are studied. Sun exposure is modeled. Even the genetics of the trees are selected to prioritize uniformity over diversity. The goal is not beauty. The goal is output. Planting starts with cloned saplings produced in controlled nurseries. These young trees are genetically identical, designed to grow at similar speeds, develop similar canopy shapes, and produce fruit of similar size. Uniformity reduces unpredictability. Unpredictability costs money. For the first 2 to 3 years, the farm produces nothing. During this phase, trees are trained rather than simply grown. Branches are guided, trunks are stabilized, growth direction is controlled, steel wires are installed between support posts to prevent trees from collapsing during storms or under future fruit weight. Each tree becomes a structure engineered to carry biological cargo. Agricultural design replaces natural randomness. By the 3rd year, flowering begins to stabilize. Pollination follows predictable windows. From flower to harvest, the countdown is precise. Roughly 100 days define the transformation from fragile bloom to export-ready fruit. During this time, the farm operates like a biological factory in slow motion. Nutrients are delivered according to schedules. Water volumes are measured. Pests are monitored through traps and image recognition systems. Any deviation is corrected early. Failure is expensive. When the fruit begins to mature, the farm shifts into operational mode. Harvest timing is critical. Mangoes do not ripen evenly across an orchard. Each tree becomes its own micro-schedule. Workers move through rows with visual standards memorized through training. Color tone, firmness, size, and stem condition determine whether a mango is ready. For low trees, harvesting remains manual. Hands twist gently. Fruit is lowered, never dropped. Plastic crates absorb impact. The objective is to protect cellular structure before the industrial process begins. For tall trees, engineering takes over. Telescopic poles with fabric nets reach into the canopy. The fruit is cut and guided downward without touching the ground. Gravity is controlled. Damage is minimized. Not every mango is chosen. Unripe fruit remains on the branch for future rounds. Overripe fruit is rejected immediately. Only mangoes that meet industrial maturity standards enter the system. At the edge of the field, temporary collection zones fill with crates stacked in precise formations. Here, heat becomes the enemy. Sun exposure is minimized. Transport begins within hours. Trucks do not wait for poetry. They wait for weight targets. From this point forward, the mango stops being a fruit and starts being a dataset. Every shipment is logged: origin block, harvest date, temperature, humidity, variety, size class, destination facility. Agriculture becomes traceable. Each fruit inherits a digital identity. The processing facility receives thousands of tons per week. Entry gates resemble factory docks more than farms. Forklifts move crates like components. Workers follow floor markings like circuit diagrams. Inside, the first phase begins: separation. Mangoes are unloaded onto wide mechanical belts that move at regulated speeds. Rotating rollers spin each fruit slowly, allowing cameras and human inspectors to identify defects. Bruises, mold, deformation, insect damage, anything imperfect leaves the system. This is not cruelty. This is standardization. Next comes washing. High-pressure water removes soil, microorganisms, and residues. Temperature-controlled baths follow, neutralizing enzymes that could later cause oxidation or discoloration. These invisible chemical reactions, if left uncontrolled, would ruin flavor, alter color, and reduce shelf life. The mangoes exit this stage cleaner than most surgical instruments. Now they wait, not in baskets, in flow. At this moment, the fruit stands at a crossroads. Some will become fresh produce shipped directly to retailers. Some will become juice. Some will become frozen cubes. Some will become canned pulp. Some will be dehydrated until only flavor and structure remain. Identical origin, radically different futures. The system does not care which path the mango prefers. The system cares which path the market demands today. Once mangoes pass the first inspection gate, they enter a space where agriculture dissolves into engineering. From this point forward, human hands become secondary. Systems dominate. The fruit moves on conveyor networks designed to eliminate pauses. Speed is calibrated to prevent pressure damage. Spacing is controlled so no two mangoes collide. Even friction is calculated. Each line is optimized for a specific destination. Fresh market mangoes are separated early. They receive minimal handling, protective coatings to slow dehydration, and controlled atmosphere packaging that regulates oxygen and carbon dioxide levels. These mangoes leave quickly, moving into refrigerated logistics chains that resemble pharmaceutical distribution more than food transport. The rest move deeper. Juice-bound mangoes enter a different reality. Their skins are no longer valuable. Their shape is irrelevant. Only pulp matters. Mechanical arms position the fruit into automated peeling chambers. Blades adjust dynamically based on fruit diameter, minimizing pulp loss to fractions of a millimeter. Optical sensors correct blade depth in real time. Every gram recovered increases yield. Every gram wasted is registered as inefficiency. The seed is separated through pressure-guided extraction units. The pulp is transferred through sealed stainless steel channels to prevent contamination. Here, volume replaces individuality. Tons of mango flesh merge into continuous streams. This is where efficiency becomes visible. Industrial crushers reduce the pulp into uniform particles. Modern systems recover over 99% of usable material. Waste streams are diverted automatically. Skins to biomass processing, seeds to oil extraction or agricultural byproducts. Nothing is sentimental, everything is optimized. After crushing, oxygen becomes the enemy. Exposure to air degrades color, flavor, and nutrients. To prevent this, the pulp enters vacuum chambers where dissolved oxygen is removed at molecular levels. This step alone can extend shelf life by months. The mango is no longer a fruit. It is now a fluid dataset: viscosity, sugar concentration, acidity, microbial count. Sensors sample continuously. Algorithms decide adjustments. The mixture enters homogenizers where pressure forces particles into microscopic consistency. Texture becomes programmable. From here, the juice flows into thermal stabilization tunnels. Heat is applied briefly but precisely. Enough to neutralize bacteria, not enough to damage flavor compounds. The balance is mathematical. Next comes bottling. Thousands of containers per hour rotate under gravity-fed filling valves. Each receives identical volume down to the milliliter. Caps seal with calibrated torque. Labels are applied by vision-guided robots. Human oversight remains. Human control does not. Parallel to this line, other mangoes move toward solid transformation. For frozen production, the process prioritizes speed over refinement. The fruit is sliced, washed, and flash frozen in tunnels reaching extreme sub-zero temperatures. Ice crystals form instantly, preserving cellular structure. Slow freezing would destroy texture. Speed protects profit. The frozen mango becomes a commodity unit, stackable, countable, shippable. For dehydration and freeze drying, the fruit enters vacuum chambers where water is removed without collapsing structure. The result is a lightweight product with concentrated flavor and years of stability. It is not fresh, it is durable. Another line feeds the canning division. Here, ripening is induced in climate-controlled warehouses. Ethylene levels are regulated, temperature curves are managed digitally. The mango reaches peak sweetness under artificial skies. Then it is processed into pulp, standardized, heated, poured into metal containers, sealed, and sterilized. Summer is preserved through pressure and steel. Across all divisions, quality control never stops. Samples are taken every hour. Microbial tests, sugar analysis, colorimetry, pH measurement, viscosity tracking. Any deviation triggers immediate recalibration or full shutdown. Agriculture no longer guesses, it calculates. By the time mango products leave the facility, they are no longer agricultural goods. They are industrial outputs. They carry barcodes, batch numbers, chemical signatures, and compliance certificates. They move into containers, containers into ships, ships into global distribution. The fruit that once depended on monsoon patterns now depends on port schedules. Nature becomes one variable among many. In this system, mangoes are not harvested. They are processed into predictability. By the time a mango leaves the processing facility, it no longer belongs to the farm. It belongs to the network. Each box, bottle, pouch, or can becomes a moving asset inside a system designed for speed, reliability, and cost control. Logistics replaces soil as the dominant force. Warehouses near ports function like buffer memories. Products wait inside temperature-regulated zones, stacked in precise patterns designed by software to maximize volume and minimize retrieval time. Forklifts move according to digital instructions. Human intuition has been replaced by routing algorithms. Containers are sealed, labeled, and assigned to vessels weeks before departure. Shipping schedules are calculated against harvest forecasts. A storm in the Pacific can affect mango prices in Europe. A strike in one port can reroute entire fruit economies. The mango becomes a financial instrument disguised as food. Insurance contracts follow it. Currency exchange rates affect its final shelf price. Fuel costs reshape where it is sold. Nothing about its journey is natural anymore. The system values consistency above all else. Retail chains demand identical color, identical sweetness, identical texture. Variability is treated as a defect. Processing facilities compensate for nature's imperfections through blending. Sour batches are diluted, overripe pulp is corrected, sugar concentration is standardized, flavor becomes engineered, origin becomes marketing. The consumer sees a label. The system sees a SKU. Behind each product stands a workforce optimized for scale. Harvesters operate in shifts synchronized with ripening cycles. Processing workers monitor screens more than fruit. Technicians adjust machines that replace hundreds of manual labor hours. Training focuses on compliance, not agriculture. Most employees never touch a tree. They touch interfaces. Agricultural labor has merged with industrial labor. Rural land now hosts factory routines. The economic impact is massive. Entire regions reorient around mango production. Roads are expanded to accommodate heavy transport. Power grids grow to supply refrigeration. Water infrastructure is rebuilt to support irrigation. One crop reshapes landscapes, but efficiency has a cost. Water usage increases sharply. Mango trees demand stable hydration in climates that often lack it. Underground reservoirs decline. Rivers are redirected. Irrigation competes with urban demand. Chemical fertilizers replace soil regeneration. Pesticides evolve alongside pests. Biological diversity shrinks as monoculture expands. The system produces abundance. It also produces dependency. Farms depend on processing facilities. Facilities depend on global buyers. Buyers depend on consumer behavior. A drop in demand in one country can collapse thousands of hectares of orchards elsewhere. The fruit is simple. The structure is fragile. Technology attempts to stabilize this fragility. Sensors monitor soil moisture by the second. Satellite imagery detects early stress. AI models predict yield months in advance. Drones scan leaf coloration to identify disease before humans can see it. Data becomes the new fertilizer. Farmers no longer rely on instinct. They rely on dashboards. Decisions are made in offices far from trees. Irrigation schedules are optimized by software. Harvest dates are adjusted by probability models. Storage volumes are negotiated before fruit exists. The mango enters markets before it exists physically. Financial systems trade future harvests. Risk is calculated, uncertainty is priced, and yet, despite the machinery, the fruit remains biological. Weather still disrupts, disease still spreads, trees still age. No model eliminates reality. The system does not seek perfection. It seeks controllable imperfection, enough predictability to function, enough flexibility to survive. By the time the mango reaches a supermarket shelf, it carries no visible trace of this machinery. It looks simple, bright, ordinary, cheap. The consumer touches smooth skin. They do not touch irrigation maps. They do not taste logistics. They do not smell energy consumption. They experience sweetness. The system experiences margins. Mass production creates a comforting illusion. Shelves remain full. Prices stay low. Supply feels infinite, but abundance is never free. Behind every stable mango display stands an invisible structure of extraction. Water is the first currency. A single commercial mango tree consumes thousands of liters each year. In regions where rainfall is irregular, groundwater becomes the primary source. Pumps dig deeper every season. Aquifers recharge slowly. Consumption accelerates. From the surface, the orchard looks healthy. Below it, the reserves shrink. Irrigation technology reduces waste, but it does not remove dependence. Precision systems distribute water efficiently, not magically. Efficiency delays depletion. It does not cancel it. Next comes soil. Monoculture changes everything. When one species dominates for decades, microbial diversity collapses. Nutrient cycles shorten, organic matter declines. The land becomes chemically productive but biologically fragile. Fertilizers compensate, they restore numbers, not ecosystems. Nitrogen, potassium, phosphorus enter the ground on schedule. Trees respond with growth, yields stabilize, but long-term resilience weakens. The soil becomes a platform, not a living system. Pests adapt. Where food concentrates, predators follow. Industrial farms respond with chemical layers, fungicides, insecticides, growth regulators. Each generation of pests grows resistant. Each season requires stronger solutions. The system enters a loop. Productivity demands intervention. Intervention creates new problems. New problems demand stronger intervention. The loop tightens. Processing facilities generate their own shadow economy. Skins, seeds, wastewater, rejected fruit, chemical residues. Most are recycled. Some become biomass fuel. Some feed livestock. Some are treated and released. Not all treatment is equal. In regions with weak regulation, runoff enters rivers. Sugar-rich waste changes microbial balance. Oxygen levels fall. Aquatic life adapts or disappears. From a distance, the industry looks clean. From inside, it leaks complexity. Transportation compounds the footprint. Refrigerated trucks, container ships, cold storage warehouses, packaging factories, plastic films, aluminum cans, cardboard pallets. Every mango travels wrapped in energy. The carbon footprint of a single fruit crosses oceans. Still, demand grows. Urban populations rise. Fresh food expectations rise with them. Consumers expect tropical fruit in winter. They expect perfection year-round. They expect low prices. The system responds. Expansion continues. More land converted, more forests replaced, more rivers diverted, more data collected. Sustainability becomes a strategy, not a solution. Certifications appear. Labels promise responsibility. Some farms genuinely improve practices: drip irrigation, biological pest control, soil regeneration, renewable energy. Others optimize documentation. Both sell under the same logo. Progress exists. So does marketing. Climate change accelerates the tension. Temperature patterns shift flowering cycles. Storms damage orchards. Drought shortens harvest windows. Heat alters sugar concentration. Regions once ideal become unstable. New regions are tested. Agriculture migrates. The mango follows climate models. Farms move uphill, toward coasts, toward new continents. The fruit adapts. The system adapts. The margin narrows, yet production increases. Because global food systems do not slow down. They compensate, they substitute, they restructure. Failure is redistributed, abundance is protected. At scale, sustainability becomes risk management, not ethics. The objective is not harmony, it is continuity. The mango must exist tomorrow, no matter what it costs today. The future of mango production will not smell like orchards. It will sound like servers. The industry is already shifting from mechanical optimization to cognitive systems. Machines no longer just execute. They observe, they predict, they decide. Modern farms are becoming sensor fields. Every tree is monitored. Soil humidity, leaf temperature, sap flow, nutrient density, wind stress, micro fractures in branches. Cameras scan canopy color daily. Infrared imaging detects disease before symptoms appear. Algorithms compare growth curves against millions of historical samples. A mango tree becomes a biological dashboard. Farmers become system operators. Instead of walking rows, they analyze probability. Instead of guessing harvest time, they receive forecasts accurate to the hour. Instead of reacting to pests, they prevent outbreaks before insects reproduce. Agriculture becomes preemptive. Autonomous harvesting is already moving from prototype to deployment. Robotic arms identify ripe fruit using spectral analysis. Pressure sensors adjust grip to avoid bruising. Drones coordinate movement patterns between trees. Night harvesting reduces heat damage and increases efficiency. Machines do not tire. They do not demand weekends. They do not unionize. Processing facilities evolve in parallel. Future lines will self-correct without human instruction. Chemical composition will be measured in real time. Flavor profiles will be modified digitally. Texture will be adjustable by software. Juice will not just be standardized. It will be customizable. Retailers will order mango products by specification. Sweetness level, 7.4. Acidity, low. Color index, premium. Shelf life, 180 days. Texture, smooth, Factories will deliver. Genetics will follow. Breeding programs already prioritize traits compatible with machines: symmetrical shape, reinforced skin, uniform ripening, predictable fiber structure. Future mango varieties may never exist in the wild. They will exist for logistics, for robots, for containers, for algorithms. Vertical mango farming is no longer science fiction. Controlled indoor orchards are being tested in climates where mangoes never grew before. Artificial sunlight, synthetic soil, closed water loops, zero pests, trees grown like hardware, fruit produced like software updates. Climate becomes irrelevant, geography becomes optional, data replaces weather. In this model, mango production is no longer agriculture. It is manufacturing using living components. The line between food and technology dissolves. The fruit becomes an interface between biology and industry. Consumers will still see something simple: yellow skin, sweet flesh, a familiar taste. They will not see the neural networks predicting flowering cycles, the satellites guiding irrigation, the genetic edits stabilizing sugar ratios, the autonomous ports routing shipments, the carbon accounting systems balancing emissions. The fruit will remain innocent. The system will not. Mangoes will continue to exist. They will be cheaper, more abundant, more uniform, more detached from nature. They will taste like summer. They will be produced like microchips. And somewhere inside this architecture, the original idea of fruit still survives. Quietly, in sugar molecules, in aroma compounds, in the soft resistance of pulp between teeth. A biological artifact moving through a technological world. Not harvested anymore, engineered into existence.